Hi, my name is Leah Reddy. I am a sophomore biochemistry and molecular biology major at Chapman University. Today, I'm going to be talking about the science of X-rays. Let's start by looking at the electromagnetic spectrum. Look around you. Every color that you see is made from a different wavelength. What do I mean when I say wavelength? Well, think of waves on the ocean, but light waves are 100 million times smaller. The electromagnetic spectrum, as seen here, does a really good job of visualizing all the different types of light that are in the world. Visible light ranges from red, orange, yellow, green, blue, purple, the whole rainbow, but it's only a really small part of the electromagnetic spectrum. So what about the rest? Well, these are lights that we can't see. Today we're only going to be looking at X-rays. X-rays range from 0.01 nanometers to 10 nanometers. Basically, this is really, really small. Even though we can't see X-rays or any of these other lights, we have machines to test that they exist and to use them to our advantage. We can use X-rays to view the inside of our body and specifically to look at bones. This is what's used in hospitals. Now let's look at radiation. X-rays, as we saw before, are really small and they're high in energy. The sun gives off all these different types of light. Well, since X-rays are so small, they come down and they enter the body. Well, when they enter the body and go through our skin, they can go into the cell. This is a cell over here, and the cell has DNA. Inside of our DNA, the X-ray or the radiation can damage and mutate it. Now we've got mutated DNA right here. We see this red strand. This is because X-rays can damage our cells. How do we protect ourselves from this happening to us? Well, we can wear lead vest. Lead is a very dense type of metal, and it won't let the X-rays pass through it. Now, why don't we walk around outside wearing lead vests? I don't go outside and wear a lead vest. How about you? Well, every year, it's estimated that you are exposed to 100 millisieverts of radiation. This is called background radiation. It's perfectly harmless and it won't do anything to you. This is from things like the sun and machines, technology. You don't have to worry. X-rays in the hospital, they use radiation to view the inside of your body, but they only give off 1 millisievert. This isn't that much compared to 100. That's why we don't really have to worry about X-rays. But if you had an X-ray every day, that would be 365 millisieverts. That's when you have to start to worry. That's why we have to make sure we wear our lead vest. If you go into the hospital, they're going to give you this vest to protect the rest of your body. If you broke your arm, they'll take an X-ray of just your arm, but cover the rest of your body with lead. This is so the rest of you is safe and you're not exposed to any more radiation than is necessary. Our guy is wearing our lead vest, which is why over here his DNA is all good. There's no mutations. Alright, so now let's look at an application for radiation and X-rays. In the hospital, they use X-rays to view your insides. How do they do this? Well, we know X-rays are so small that they can go into the skin, but they can't go through the bone. Bone is made up of calcium. That's why your parents tell you to drink your milk. Build healthy, strong bones. Well, that has calcium. The calcium is very dense and it won't let the X-rays pass through. This is similar to that idea of lead and how it won't let the X-rays pass through. This is really important for doctors because they can use this material or the way that X-rays go through the body to view your insides. Up here, we see a picture of an arm. Specifically, we're looking at an elbow. It's labeled right here on our guy. Every image is labeled with an L or an R. This is important for the hospital workers. In healthcare, they're going to label every image with an L or an R for left or right so that future people can view the scans and understand where it's coming from. You don't want to just take a picture of an arm and not tell anyone what side it's on because then they won't know. This is really important. The doctors who view these scans are called radiologists. A radiologist will help take the scan and view them. They use this information to tell if a bone is fractured or if a patient needs surgery. X-rays are totally harmless and totally safe. I work at St. Joseph's Hospital in Orange, California, and I see the X-rays performed all the time. They're really cool, and I've had them done before. Totally safe. The next image we're going to look at is something of a foot. You can see here all the different bones of your foot. You've got the little bone, and then you've got your heel. It's really interesting, I think, to be able to look at this scan and learn information from it. The next scan we're going to look at is a chest scan. You can see all the bones in your chest from your spinal column, all of your ribs. You can even see denser tissues. So X-rays, remember, they won't pass through dense things like lead or calcium, your bones. Well, this right here, this is your heart. Your heart is full of blood. When it has a lot of it, it becomes dense and it won't let the X-ray pass through. That's why it's visible on this scan. The next one we're going to be looking at are your legs. You can see the knees of this patient right here and all their bones. This is really interesting, again, for the future, so they can see what a healthy scan is compared to someone that's broken. All of these pictures are of healthy people. I hope you enjoyed learning about the science of X-rays. Please leave any comments or questions down below. Thank you so much for listening.